2.4f, adding with a different large denominator. When adding fractions with large denominators, it is best to use the prime factorization method of finding the LCM of the denominators. Remember that when adding fractions with different denominators, we need to first convert them to fractions with the same denominator. And we do this by multiplying top and bottom by the same amount so that both fractions have the LCM as the denominator. You'll see what I mean through these examples. So let's go through this. Example 1. Compute 1 over 256 plus 1 over 150. So let's first, we have to find the LCM of 256 and 150. So we use the prime factorization method. So I write out 256 and I write out 150, and I'm going to do a factorization tree for both. So I know 256 is 16 times 16, 16 squared, right? Well, I can break these down into 4s, because 16 is 4 times 4. And I can break each of the 4s down into 2s. 2, 2. It's a lot of 2s. So 256 actually equals 2 to the 1, 2, 3, 4, 5, 6, 7, 8th power. 2 to the 8th. That's 256 is prime factorization. So now I prime factorize 150. This is 15 times 10. So 15 is 3 and 5, and 10 is 2 and 5. So 150 is actually 3 times 2 times 5 squared, because there were 2 5s. So let's look at these. To find the LCM, I have to have the largest power of each unique factor. So let's go through what unique factors do we have. We have 2s, we have 3s, we have 5s. What's the largest power of 2? Well, it's 8. So 2 to the 8th is in the LCM. The largest power of 3 is 3 to the 1st, so we leave that alone. And the largest power of 5 is 5 squared. So our LCM ends up being 2 to the 8th times 3 times 5 squared. This is actually, if you type this into a calculator, 19,200. So what we have to do is multiply these fractions up here, top and bottom, by some number to get the denominators to equal 19,200. Well, how are we going to do this? There's a quick way. We don't actually have to think about this too hard. We know that 256 is 2 to the 8th. What is it missing? It's missing 3 times 5 squared. So all we have to multiply 1 over 256 by to make the denominator 19,200 is 3 times 5 squared on top and bottom. So this ends up equaling 25 times 3, which is 75, over 19,200. So 1 over 256 is equivalent to 75 over 19,200. Likewise, to get 1 over 150 to have that denominator, we multiply by 2 to the 7th, because there are 7 2's missing from the LCM and the prime factorization of 150. So this ends up equaling 2 to the 7th is 896. Oh, I'm sorry. It's not 896. 2 to the 7th is 128. And 150 times 2 to the 7th is the 19,200. So now when we add these together, all we have to do is add the numerators now because they have the same denominator. So 75 plus 128 is 203 all over 19,200. And that would be our final answer. So let's go through another example, maybe with some real-world applications. Say I have 2 drums of oil that I'm trying to combine into one. Assume that the drums are the same size, and the first is 27 over 81 full, and the second is 200 over 567 full. How full is the combined drum? So what our problem actually is 27 over 81 plus 200 over 567. So first we have to find the LCM of the denominators, right? So the LCM of 81 and 567. To do this, since they're large numbers, we're going to use the prime factorization trees of both of these. So 567 is actually 7 times 81. 81 is 9 times 9. And 9 is 3 times 3. So if we count the lowest most rungs, 567 is actually 7 times 3 to the 4th. 81 is 9 times 9, and 9 times 9 is 3 times, or 9 is 3 times 3. So 81 actually equals 3 to the 4th. So as you can see, what we really only, the LCM is just 7 times 3 to the 4th. And we only have to multiply the 27 over 81 by 7, since 567 is actually the LCM. So let's go ahead and do that. Multiply top and bottom by 7 here. So 7 times 27 is 189 over 567 plus 200 over 567. And when we add these together, we just get 389 over 567 as our final answer. So our combined drum of oil is 389 over 567 full.